Okay. All right. So we spent last half an hour just building the base up, right? Excuse me. And now we're at a point where we can start looking into each cloud provider and understanding what the basic constructs that they provide, right? So the first one we're going to look at is AWS. So when you start as a network engineer in cloud, you would expect that, hey, I'm a network engineer, I'm going to go and start consuming and talking and thinking about networking. But that's not how it's going to work. So the first thing that you'll have to encounter is services or understanding of how the cloud provider has built their environment. And you have to, work your way through these services before you can get to the networking pieces. So there are hundreds of services for various kinds. You will see the focus of the cloud provider is at application level services. Networking and infrastructure is not very attractive for most cloud providers because they don't make really money at infrastructure level there, or network infrastructure layer. Their main revenues are from services and applications that they serve. So this first service that I want to talk about in AWS is EC2. So EC2 is the compute service. So when you need to instantiate an instance of Windows or Linux or Unix or Ubuntu or whatever kind of instance that you need to spin up, you'll have to go and spin up an EC2 instance. Once you spin up the EC2 instance, you'll have a lot of options about the size and throughput, and of course the cost of each instance will vary depending on your choice. Then you have something called IAM, Identity and Access Management, which is how you have access into different parts of the provider. So you set up your when you sign up, let's say if you're doing a personal account, you will be the root, but when you are part of your organization, you probably will have some limited access into which aligns with the responsibilities that you have. VPC is the virtual private cloud. So VPC is a networking construct which is like a walled garden that you have, and you spin up your EC2 instance within a VPC. So a VPC is basically an island of its own. Anything in the VPC can talk to each other, but when it goes out, by default it can't, and you need to use some different kind of services to make sure that they're able to talk. Then you have S3, which is one of these storage service. Direct Connect is a way for customers to connect their on-prem location to the public cloud provider using a dedicated link. So you can go and consume the services in AWS via internet as well, but it will be over public internet. It will be more costly, and it won't be enterprise grade, and you won't have let's say private IP addressing based connectivity between multiple VPCs and stuff like that. So a lot of customers would use Direct Connect to get a high level of performance, cheaper connectivity into the cloud provider. So essentially what you're doing is you're putting a wire between your data center and AWS cloud or AWS data center. So when you deploy a Direct Connect, you choose which region you want to connect to. So you may choose, hey, I'm in New York and I want to connect to North Virginia because that's my closest region, or that's where I have most of my workload. And there are other services for DNS and CDN and whatnot. So now let's build this environment. So we're gonna see the different pieces and how they come together. So the first thing is, as we talked about, you pick a region. So let's say you pick North Virginia or Oregon or Ohio, whatever region that you pick. Within that region, you create a VPC. When you create a VPC, you define CEDAR. So CEDAR is the higher level network that is defined, that defines the VPC. And then you will carve subnets out of the CEDAR for use inside the VPC, right? Then within the VPC, you have availability zones. Okay, so basically I have multiple availability zones, and I want my VPC to have instances which are in multiple availability zones. So if one data center, which is our physical location that is represented by availability zone, goes down, I have another availability zone where those instances can live. Now, within the availability zones, you will carve your subnets. So when you create a subnet, you will say subnet one, what's the subnet, IP address range, and which availability zone it's gonna be in. A subnet is confined to one availability zone. It can't span multiple availability zones. Then you spin up your EC2 instances. And so this is the relationship between EC2 instances within the larger constructs, larger context of the constructs. Now, between the subnet 1 and subnet 2 lives an implicit router, which you never see, but that's the guy that routes traffic between these two. There's a lot of details in here, and of course, we can't cover all of that today in this conversation, but essentially there's limitation on the IP addressing. So the first IP is the implicit router IP, so you can't use that, and then there are like 4 or 5 IPs that you can't use by default because they're used by the AWS services. And when you have 2 instances which are in two subnets or within a subnet in the same VPC, by default they'll be able to talk to each other, except if you have some security in place. So let's look at the security pieces. So you have 2 kinds of security. One is the security group, and then you have a NACL, network address control list. So security group, number one thing, is something which is limited to a single VPC. So if you create a security group, that security group can only be used within the VPC. So if you have 100 VPC and you need same security, let's say you need a security group that blocks port 22 traffic, right? You need to create that 100 times in each VPC. It's not a global resource that's applicable and available across different VPCs. Then you can use a single security group for one instance or multiple instances. The best practice for most security teams is to use a single security group per instance. Why? Because if you have, unless the instances are exact same. So if you have a web server in 10 instances, yes, use same security group for all those 10 instances. But if you have a web and an app or app 1 or app 2, use separate security groups. Because if you use same security groups for multiple instances, that means you are giving too much access to something. And if the instance goes down, the security group cannot be removed because it is being used by somebody else, right? So you should make sure that the life cycle of an instance is tied to the security group. So when the instance goes away, the security group goes away as well. Then you have a concept of internet gateway and virtual private gateway. Internet gateway is how you get access to the internet. And then virtual private gateway is the VPN endpoint if you need to connect your VPC to on-prem or something else using VPN. So the security group was at the instance level. So the next level is NACL, network address ACL. The difference between security group and NACL, one of the differences is that security group is stateful. So you don't have to create rules for bidirectional traffic. You create one direction, the other is automatically taken care of. But NACLs are stateless, so you need to create rules for both directions. And then you have route tables, and the route tables connect to a router that, the implicit router I was talking about. The thing about for this whole thing is that you need to build each of these pieces individually. So you need to create the route tables individually, and the NACLs and security groups and instances and subnets and the connectivity. So if you have to do it for 1 VPC, 2 VPCs, 5 VPCs, that may be okay. But when you're enterprise and you need to do this at scale, it's not easy. So the next level of concepts are around gateways. So there are various kinds of gateways available. So I talked about internet gateway in here, and I would just add one more thing. And I know this is going to be a lot of information. So, but that's why it's a boot camp style conversation. So these subnets, when you create these subnets, you can define these subnets to be either private subnet or public subnet. So if you define it as a private subnet, it cannot have direct access to internet. But if you define it as a public subnet, then it will automatically have an internet gateway attached with a quad 0 default route to the internet. If you need the private subnet instances to access the internet, you'll need to deploy some kind of NAT device in the public subnet, which would allow you to have access to internet. So essentially, this is how it would look like. So if where's the pen? Okay, so this, let's say this is your private subnet, right? And this is your public subnet. So this guy has automatic access out. Now, if you need the private subnet to have access, you need to deploy some kind of NAT device, which will give you access to the internet, and these guys will need to be pointing to this NAT device for internet. So this is something that you'll have to take care of yourself. All right. So we talked about IGW, we talked about NAT gateway, and then there are other kinds of gateways, transit, VPN, and direct connect. So let's build them in a diagram. So you have let's say these different regions, US West 1 and East 1, and you have multiple VPCs in them. If you want the VPCs to talk to each other, so in AWS, you can deploy something called a transit gateway, AWS Transit Gateway, TGW. When you deploy this TGW and you do the necessary configurations, and we'll talk about the limitations there, your VPCs will be able to talk to each other. Now, if you need a on-prem location to have access using fast path connection, which I mentioned earlier, is called direct connect. This is not VPN. This is private leased line connection from your environment using a provider like Equinix, CenturyLink, or somebody like that into the physical AWS location. So in here, at the bottom, you have CGW, which is customer gateway. So this is the appliance that you own, right? Then this icon is for direct connect, right? So this is like Equinix or some other kind of cloud provider location where you connect to, and then it would connect you into the cloud provider. So this is the demarc point. Below this is you and other and other service provider like Equinix, and above this is your public cloud entity. So in here you have the concept of DX gateway. So this, I'm simplifying this conversation. This on its own is a multi-hour conversation, which we do at the professional level certification. So the DX gateway is a global resource which allows you to connect different transit gateways with each other. However, there are several limitations in DX gateway, and one of the key limitations is that it does not allow this traffic pattern. You cannot go east-west between different regions via DX gateway, right? Okay. Okay. Then the next piece you have is, let's say you have a certain VPC that needs connectivity, a VPN connectivity. It could be coming from your on-prem, or it could be coming from another branch location that needs to connect to this specific VPC. So you can spin up a VPN gateway, which is localized to a specific VPC only. So once you have access to this VPC using this path, you have no access to any other VPC. It's localized access. And we talked about IGW for internet access. Now let's talk a little bit about the transit gateway. So the transit gateway is essentially not a router on its own. It's a fleet of EC2 instances that they spin up depending on how many instances you have, which availability zones, and whatnot. So you have AWS region and VPC1, VPC2 that need to talk to each other. You spin up a transit gateway. And then you have a concept called attachment. So you attach a VPC to a transit gateway. It's a cloud provider service, native service. You can have 5,000 attachments, and each attachment can be 50 gig at burst, not sustained. You can have multiple route tables at TGW. You have different attachment types. One attachment type is when you're connecting to VPC. Then you have other attachment types when you're connecting to VPN. Um, this is something which is available only in AWS. This is not something which is available by any other cloud provider. Now, at a high level, this looks cool, right? I got a transit gateway and I can connect all my VPCs together and my life is good. However, the reality is a little bit more complicated. So when you have multiple VPCs connecting to transit gateway, you so the AWS only manages the transit gateway route tables. So transit gateway is single entity and they manage its route table, but all the VPCs that are connecting in, they are your responsibility as a customer. So your responsibility is routing table management. So the creation of those route tables, all the subsequent updates to the route table. Let's say this is subnet A and this is subnet B. So you need to go and program the route tables at VPC1 to say, hey, subnet B, go this way, and here you have to create similar routes. Let's say you have a new VPC coming in, you need to go in the route table at these VPCs again, and you need to update the route tables, and so on and so forth. So this, of course, if you have a small static environment, and then it may be okay, but for any enterprise grade environment, even with 5-10 VPCs, this becomes very problematic because you have a lot of possibilities of human errors and people making mistakes, fat fingering, administrative overhead of updating the route tables and stuff. There are some people who would say, hey, why do I need to manage these routes individually? Why don't I create a 0/0 and point it to transit gateway so I don't have to worry about this? This only takes you so far, because once you start using more cloud services, you will see that that you will have requirements. For example, the VPC has something that needs access to internet. Then you have some things that need private link access to specific services. Then you have peered connections, and there are other various kinds of requirements that very quickly negate the approach of quad zero going to transit. Another limitation is that if you are connecting a on-premise site using VPN, you are limited to the throughput of 1.25 gigs only. So we'll talk a little bit more about this throughout today, but anytime you're doing VPN into the cloud, you will be limited to the throughput of 1.25 gigs. Then there are scalability issues. So if you have on-prem coming into the transit gateway, let's say doing BGP, it's limited to 100 routes. So if the funny thing is that when you get the 101st route in by mistake or what, you're not careful, the entire BGP session goes into idle state with no alarms and alerts. And it will stay in that state until you go back down to 100 or less routes. And there's no VPC seeder summarization. So if you have different VPCs that are advertising their routes down, there's no way to summarize these routes. There's no overlapping IP support. So a common question that we get from customers is that, hey, I need the traffic between these VPCs to go through firewall, because VPC1 is dev, VPC2 is production, and I need firewall in between or something like that. And those kind of things are very, very problematic when you try to do via transit gateway. And we'll talk a little bit more about that today, inserting firewalls. So there's a lot of things that Aviatrix does in this perspective, and we'll talk later about it, but I think it's a good point now to introduce it. So the first thing is VPC peering. So by default, when you don't have the transit gateway, you do something called VPC peering, where you take two VPCs, you peer them with each other, and you create a layer 2 connection between these VPCs. There's no transitive behavior in here. So what that means is that if you have a VPC1 and VPC2 and VPC3, and you want VPC1 and VPC2 to be paired and 2 and 3 to be paired, and you want, hey, how about VPC1 can use this path to talk to VPC3? This is not possible because there's no transitive behavior in this VPC peering. That means you need to create all of these peering individually in a full mesh situation. And this is not something which is limited to AWS. It's the same way that every cloud provider does. AWS, Azure, GCP, OCI, everybody does is exactly the same way. Okay, so the replacement of the peering is AWS Transit Gateway. So Transit Gateway tries to help mitigate this problem, but with the complexities I mentioned about route table, orchestration, BGP management, simplification, additional route engineering. For example, when you have new routes coming in, how are the VPCs gonna know about these routes? So let's say you have a new route that just got advertised from on-prem. How would the VPCs know about this route, right? So Aviatrix, basically what it does is it manages the routing and the life cycle of the transit gateway and your VPCs. So as a customer, you never have to manage these things manually. So all the propagation, when you have new routes coming in, all of those things are taken care by Aviatrix automatically for you.